Welcome to the fourth video in this web scraping series, where we will show you everything about web scraping, from how to collect data, how to store it, and even how to avoid getting blocked. In part 1 we built a basic scraper, in part 2 we cleaned it up to handle dirty data, and in part 3 we saved this data to S3 and also to MySQL and Postgres databases. We will be working from the code in these parts, so make sure to check them out if you haven't already. In this part, we are going to explain how we can make our scraper more robust and scalable by handling failed requests and also by using concurrency. Retrying is quite an important concept when it comes to scraping. It's not just relevant to scraping, even if you request data from an API, it's good practice to have a retry strategy. Sometimes when you scrape data from a website, the website might implement a rate limit. A rate limit is a block that a website will put on you temporarily. Because of this, we may need to wait a little bit of time and then try again. Also, some sites might have bot or human verification, which might block our scraping. In these scenarios, we might want to retry the request a number of times. Network delay is a big contributing factor to slowing down web scraping. Even though it looks fast, we are sending each scraping request one after another. Each time we send a request, there are small delays whilst traveling across the network. If we send them sequentially, this can cause big delays when we send a large volume of requests. As you can see by this picture, there are two main parts happening when we initiate the scraping of a page. The CPU processing time to actually initiate and process the scraped data, and then the actual wait time for each request. This is the time we have to wait for the website to respond. Because we're doing these one after another, the next request will only start once the previous one completes. As you can see by this picture, by using concurrency, we're able to open multiple requests at once. You can see in this example that we are making 3 requests. 1, 2, and 3, and they are all being processed and waited on around the same time because each is running on a different thread. This reduces the overall amount of time of execution. So to get started with retries, we're going to start by creating a retry logic class. We're going to define a constructor, which takes a retry limit variable with the default value of 5, and an anti-bot check variable with the default value of false. The retry limit is the number of times that we want to retry, and the anti-bot check is just a boolean with a default value of false that will decide whether or not the anti-bot check is enabled or not. We'll then make a function called makeRequest, which takes a URL and a HTTP method. In our case, it will default to get, and it will also take a dictionary of keyword arguments, which allows us to pass in a dynamic number of arguments. We will set the default value in the keyword arguments dictionary for allow redirects to true. And then we will loop over the retry limit, so in this case it would be 5, so 5 iterations. We will create a try except, and then we will create a request using the request library. Pass in the method, the URL, and our keyword arguments. If the response status code is 200 or 404, and if the anti-bot check is enabled and the status code is 200, then we will call the passed anti-bot check function, pass the response in, and if it hasn't passed, i.e. it's false, we will return false and the response. We will default and return true in response at the end of this function. And we will catch an exception and print error. Outside of all this, we will return false and none. We will then create a function called passed anti-bot check, which takes the response as an argument. And in here we're doing a simple check to see if the response contains robot or human, which might indicate whether or not the page has an anti-bot check on it or not. If that text is in the response, we will return false because we have not passed the check. However, if it's not in the text, then we will just return true. Now if we scroll down to our main function, we can create an instance of the retry logic class. And we can pass in a retry limit of 5 and anti-bot check is false for the moment. So we're going to do some cleanup here and create a new function called scrape page. This will help us for this retry logic and also for the concurrency later in the video. So this function will take a URL, and the first thing we will do is remove that URL from the list because we've already scraped it. We will then make a request using the new retry request object that we created. If the response is a status code 200 and it's valid, then we will just copy the code from the previous scrape function because the logic is the same. And we will paste that there. As you can see, we're still looping over the products that gets returned, we're still adding the data to the data pipeline, and we're still going to the next page in the list. Because we've moved this to another function, we can delete the original start scrape function. Now we have a single function called scrape page, which will scrape an individual page. So to add support for concurrency, we will create a function called start concurrent scrape. It will take a number of threads, which will default to 5, and we will create a while loop that says while the length of the list of URLs is greater than 0, i.e. when we still have URLs that need to be scraped, we will call concurrent.futures.threadPoolExecutor. The thread pool executor will manage the threads in the pool, and we will pass number of threads to this to assign how many threads we need. We will then call executor.map with the new scrape page function and the list of URLs passed as an argument. In our main function, we will then remove the old call to the start scrape function and instead call start concurrent scrape and assign the number of threads to be 10. Before we run this, we need to remember to import concurrent.futures. Now when we activate our virtual environment and run the script, you can see it creates the product data.csv, and this was scraped concurrently. So that's everything we're going to cover in this part. We hope you have a good understanding of why you need to retry requests and use concurrency for web scraping. As always, if you have any questions, please leave them below. In part 5 of the series, we will learn how to make our scraper production ready by managing our user agents and IPs to avoid getting blocked. Make sure to check out that video. Also, don't forget to like, comment, and subscribe.